Mathematical models, building functions. So let's take a look at this problem. Now, every problem we do are going to be completely different in a sense. That it's just going to be different ideas we use. The basic idea of getting in terms of a certain variable are the same, but that can look a little different too given each problem. So let's take a look at this one here. It says a rectangle is inscribed in a semicircle of radius 2. See the figure. Let P equal xy be the point in quadrant 1 that is a vertex of the rectangle and is on the circle. Okay, let's go to the figure down here. So this is our design here. Here it is. This is what they were saying in all that blah, blah, blah that you heard. Okay, now this says, for part A, it says, express the area of the rectangle as a function of x. So I was just reading here. Okay, so we need to express this rectangle as a function of x. So we all know the area of a rectangle is A equals L times W. And that's no different. We're all familiar with that idea. Okay, so what that means for us here is I have to find my length and my width. Now listen to what this says here. It says express the area of the rectangle as a function of x. So that means we have to get our L and W in terms of a function of x, or just x's. That's really what that means. So what I'm going to do is I'll pick a different color here. We'll go with green. Green's a nice color. Okay, so what I'm going to do here is I need this length. That's the first thing I need. Now, this length could be anywhere between 0 and 4, if you think about it. Because it could go all the way to these edges here. And that's where it stops. That's as far as it can go as far as the length. That's the biggest length I could have. And that would be a length of 4. But the width would be 0. It would actually be that rectangle. Okay, so if I went a little bigger, I could go a little bigger and it'd be more narrow. Okay, so we can get all kinds of variations of rectangles here. Okay, but we're just trying to express this area as a function of x. So what that means is I need this length in terms of x if possible. And if you think about this idea here, this distance from here to here is x. And this distance from here to here is x. Okay, because I'm going out from 0 to x, and that's just x. And then the other way, I could have it the same way. So this length together, the whole length, I should say, not length together, but the whole length is 2x. So I can say L equals 2x. So that's the first thing we can get from this. So now let's talk about the width of this thing. Okay, so when I look at this distance here, I can say because this distance from here to here was x, I can say the distance from here to here is y. And that's okay, that's true. But can I take it a little further? Can I say that it's, or write it as a function of x? And I can. And the reason why I can is because of this. Let's take a look. I know y equals the square root of 4 minus x squared. So that tells me then that this distance from here to here is going to be y, but I can also call it the square root of 4 minus x squared. Okay, so now I have everything I need for this area formula. So A equals L times W, and my L is 2x, times my W, which is the square root of 4 minus x squared. So that's actually our answer for this one. So again, when it tells me the variable there, that makes it clear what I need. Now, if it said as a function of y, then I would take this equation here and solve it for y, and that would give me my width here. That would give me this value. That means just a slight change of the problem just by a variable changes what I do here. So just kind of keep that in mind as you go through these. Now, I gave myself too much room for that, didn't I? And if I need the extra room, I'll just scoot it up. But let's take a look at number B now. Number B says express the perimeter P as a rectangle, of the rectangle as a function of x. So now what they're saying is I have to know my my perimeter formula. And if I knew the formula, I would know that P equals 2L plus 2W. And I'll explain why that is. If you think about the idea of this of this perimeter. Perimeter is distance around. So I'd have this distance, and that'll be L, 1L, right? Plus 1W, plus another L, plus another W. So really, I have 2L plus 2W. And that's where the formula comes from. Okay, so what we're going to do now is we're going to find the perimeter of this thing. And we actually have all the information we need already just from part A. Because we know our length is 2x, and we know our width is square root of 4 minus x squared, because again, it's set as a function of x. So our perimeter formula then, in terms of a function, as a function of x, is going to be 2 times 2x, because my L is 2x, plus 2, and then my W is square root of 4 minus x squared. So there's my formula. And again, I can clean that up a little. The first one I can't. This one I can and I should. If I don't, I'll probably lose a point. And that's the best I can do. All right, so there it is. So there's my formula P. And I should write this formally too here. Not that I didn't already, but there is my other answer there, my first answer. Oops. All right, there it is. So now let's get on to the third one here. Now the third one is a little more interesting here. You know, once we get those set up as far as the dimensions, we're good. Okay, now for the third one, it says A equals AX, graph it. And it says for what value of X is A the largest? So that means I'm using this formula up here again. And I want to find out where my function is the largest at. So what I would have to do here is find out where this, for what X, is that going to give me the largest, the biggest number. That's really what I'm looking for here. So I just took a picture of my calculator here for this part C because it said graph it, and this is how we do it. We're just going to do it on our calculators. And what you notice here is that right here is going to be the highest point, or the highest y value. That's where A is the largest, because really my A is my y here for this function. So we're looking for that value. And what you would do is you would go to calculate on your calculator. Hang on, let me show you that for a second. I'll just take a picture of the buttons. So let's head here. So this is the calculator I'm using right now, the TI-84. So the first thing I did was click on the y equals here, and it brought me to this screen. And then I just typed in my function, so I hit the 2 there. That's a 2 in front there, you just can't see it. And then the X comes from this button right here. And then I have to put times after it or it gets weird. And then I did the square root button, which was the second button, and this X squared button, because above it you see the square root button. And then I just kind of typed that in. And then to get the exponent here, I typed this X key again. And then I hit the up caret and then the 2. The up caret is what gives it an exponent. Okay, and once I typed that all in, then I went to graph. And the graph button, when I hit that graph button, this is what I see. Not with this maximum stuff here, just without that. But that's essentially what I see there. And so now once I put it in and graph it, or I don't even have to graph it. Once I put it in here, I can hit this second key and the trace button, because if you look just above the trace button, it says calculate. So if I hit that second key and that trace button, it's going to bring me here. And I want a maximum, so I click on that, or just scroll down to it using this scroll button here. And then once I do that, I get this screen here. And then I have to, it won't give me this right away. It'll say, hey, left bound. And it'll be over here somewhere. So I click over here, and then it'll say right bound. Then I click over here. And then it says guess, and I don't move when it says guess. And then it'll put me up here at the top. And then that's what I see when I get this screen here. And then that's when this pops up here. And then you can see that for what value of X is A the largest. and that would be here, and my x would be 1.41, which actually is the square root of 2. And from there, if I needed to, I can say the maximum area would be 4. I could also say that too from this equation here. So there's my answer for that one.